Thanks very much for your time, Dave and Terry. This is Mike Anthony at the University of Michigan. I have the privilege of working with my colleagues, Dave and Terry Flint. I'd like them, if they could, explain a little bit about their expertise in this area, what they do here for U of M, and then we hope to get this session done in about 30 minutes. So Dave, do you want to say a little bit about what you do, what your experience and your relationship to this document is?
Okay, currently I sit on the QEI committee for A17 standards and also the A17.4 emergency evacuation of entrapped passengers from elevators. I vote on those committees. They go to the main committee, A17, that approves them. Background, I'm a qualified elevator inspector, QEI 1 through NACIA. I have 46 years in the business. Been through from installation to managing companies and worked for the university for 15 years before I recently retired. So that's pretty much it, you know. So, Terry, you want to jump in?
Yeah, my name is Terry Flint. I am the Elevator Program Manager for the University of Michigan. I have about 20 years of experience in the elevator industry. I started in the field and have worked my way through sales, contract management, and supervision. I am also a qualified elevator inspector, QEI 1 through NACIA. I also sit on the State of Michigan Elevator Safety Board and represent owners and lessees.
Mike, if you get to, we're both members of Elevator U. Terry's the current president of Elevator U, but we also belong to other organizations such as ASME, NACIA. We have certifications from ASME. So there's a whole wealth of background that Terry and I possess. So that's our background. Now let's get started towards the changes that are proposed for the A17.1 standard for elevators, safety for elevators and escalators. In the proposed changes that would be in the next edition, which is supposed to be 2016, but that could change depending on ASME and whether or not they get the document out on time. So if you start down and start through the process, you'll see that the first process, Nick, start flipping the pages, Mike. That one right there, you'll see that this is dealing with rack and pinion elevators. Rack and pinion elevators are typically for construction purposes, temporary elevators, that type of things that mounts outside the building, sometimes inside, but very few passenger elevators on a rack and pinion elevator because of the speed, because of the noise. They have improved. They're starting to come out in the market as a viable means for a slow speed elevator inside a building, but we haven't picked up on that yet because of cost in the noise issue. So my intent is to go and just go right through section 4, the rack and pinion elevators, and you'll come to, there'll be a little section on 5. Now, right there, Mike, back up just a little bit where you had, keep going, 2 more pages. Okay, you'll see that it makes reference to Section 8. Section 8 is a keeper of testing maintenance, repair, and modernization capabilities that are listed for all devices in the elevator code. The rack and pinion elevators, like I said, we at the college level don't see a lot of them that are maintainable by the college or university, or do they install them? They usually hire a contractor to install them and then use them for a construction project, and then they're torn down. So just to make sure everyone knows that Section 8 of A17 deals with all types of elevators, the testing, the maintenance, the repair, the modernization. Okay, so let's go on. The next section is 5, and you'll see that 5 is dealing again with some of the qualifications for rack and pinion. So we're going to pass by that and go to, it'll be, once we get past that, we'll go to on section 5, you'll see that most of it deals with the rack and pinion and the setup. So we're going to go down to section 2, which is right there, and that's TN 09-1466. Let me give you some background on what the TN is. The TN is technical notes that are presented to committees. And if you look at the 09, that's when the inquiry was made, the year 2009. And you can see there's quite a discrepancy between 2009 being asked the question and then moving to 2015 is what we're in. So it's taken them 6 years to address this.
Yeah, I'm glad you point this out, Dave, because as I've said in many places on our blog and elsewhere, is that these are very fundamental structural changes, and that typically they will take 6 to 12 years. I like to say optimistically 3 to 9, but some of these ideas, you have to get interest groups to acclimate themselves to the possibility. And of course, there's always a vetting process, which sometimes is technical. Very often it's more political, economic. But in any case, I'm glad you pointed out the time frame, that why it's necessary to hang with this for so long. As I also try to make the comparison with our court system, many times people will say, gee, I'm going to give up and settle out of court because to put it through the court will be a decade. Well, almost identically things happen this way here in this space. So anyway, that's my little interjection there on how long it takes a lot of this stuff to happen. Go ahead, Dave.
So you're looking at TN, and the ASME is going to move away from the TNs and TRs in the future because of harmonization, and that's something that we'll discuss after we finish this. Harmonization of codes have started. A17.1 is the Canadian and U.S. code, and it's one book. It's published as one, but certain references in there will refer to the National Building Code of Canada, which refers to B44, which is the same code as A17, but a different interpretation from the Canadian point of view. So we're an international code. It's used widely across the world, and we can get into that at the end. So TN 09-1466 deals with the issue of keeping the stop switches operational when the car goes into fire service, so that a firefighter would have the ability to stop the car should he decide that it's necessary. Prior to this, all stop switches were rendered inoperative when it went on to phase 1, so that no one could stop the car in phase 2 as well.
What is phase 1 and phase 2?
Yeah. So it's a clarification to make it safer for the firefighter.
Could you explain what phase 1 and phase 2 are?
I can. It's going to take a little bit of time, but initial fire recall is triggered by a fire alarm initiating device that is in close proximity to the elevator, either in the machine room, the hoistway, or on the lobby floor. When that triggers, it sends a signal to the elevator controller to return the car to the egress floor, or rather than the egress floor, the designated level. The designated level is usually the egress floor. There's also an alternate floor so that if the fire alarm initiating device is triggered at the main floor or designated level, it goes to an alternate floor. When that happens, that's phase 1 of fire recall. When you go to phase 2, it's when the authorized person that is going to operate the elevator, such as the fire department or an elevator person, goes into the lobby or the fire command center, turns the key switch to the on position so that it would go into phase 2. And phase 2 is where that particular firefighter or authorized person has complete control of the car. It does not respond to any hall calls or any other calls other than the person in the car controlling it.
Okay. I can see why you said we had to be aware that it's a highly nuanced concept. Probably at least as nuanced as the more common occurrence, which is what happens when people get stuck in elevators. But that's not this discussion, so that might be a separate teleconference. But okay, I'm sorry, Dave. It's informative. I just wanted to put that perspective on it for our audience. Go ahead.
Terry, you got anything to add?
No, you explained it very well.
Okay.
Where to next, Chief?
So I see no problem with TN 09-1466, unless someone else does. But it's going to be part of the national standard. All these revisions that you're putting forth right now are deemed safety issues and or clarification editorials so that it's better understood. So I'm on to TN 10-0223. Okay, again, the 10 is the year that it was questioned. Someone wrote a question to the Standards Committee. It went to the subcommittee. The subcommittee made this recommendation or change and is proposing it for the next edition of A17.1. So it has to do with, if you look at the rationale, it's dealing with Lula elevators, which is Section 5 of A17. So Lulas are limited use, limited access elevators. It's to clarify the safeties because you now have to clarify the requirements covered by this section to include all types of hydraulic Lula elevators. This applies to hydraulic Lula elevators. Changes were also included to clarify that safeties operated by inertia are an alternative to speed governors on roped hydraulic Lula elevators that have an overspeed valve conforming to 3.19.4.7. That is, again, a clarification in the addition of the overspeed valve instead of just a inertia-activated safety device. This does cost money, but it's already in the code for a speed governor where the inertia-activated device, the governor, trips the safety on the car. When it pulls the rope and sets the safety on the car, it's doing the same thing as what the overspeed valve was. Hydraulic manufacturer says, well, why can't we use an overspeed valve rather than just the safeties? It would be less impact and less damaging to the equipment. And that's why it's moving forward with that, because the engineering data supported it.
Okay.
Questions?
I like the sound of engineering data. Go ahead, Chief. It's your show.
Okay. We're on to TN11-1486.
Go.
Okay, what this deals with is a device that most colleges do not use. When they use this type of device, it's very specific in that if you look at the rationale, provides a practical limit for the operation of a device, as it would require holding the operating button for 50 seconds. Jurisdictions in Canada have permitted Type B material lifts to have a travel greater than 5 meters for many years, with no adverse consequences. So they're using historical data to support the change in A17.1 from the American side, or the United States side, to be more in conformance both in Canada and the U.S.
Mm-hmm. Okay, so that just triggered a thought that I had in our hopper, which is that we want to see the degree to which manufacturers can supply usage information to us. So again, following up on my comment about how much I like engineering data, no matter how sketchy it can be, sometimes sketchy information coupled with anecdotal and experience works. But I like the idea here, and I hope that in the future the manufacturers who are listening to this will give owners more access to usage data so we can design accordingly. Yep.
And what triggered this is the TSA in Ontario.
Mm-hmm.
They're the safety authority technical standards for Ontario,
Mm-hmm.
and they're the enforcing agency, or the AHJ, for Ontario. And they have very good records. They enforce much more stringent than the U.S. So any data that they supply is considered quite valuable because, as you mentioned, manufacturers are very hesitant to supply data because it ends up in court. And when it ends up in court, sometimes their own data hurts them in a case. So
yeah, so we have to be careful. The manufacturers who listen to this, I like to say we're in the fine line business. I try to repeat it to each of our opposing stakeholders, manufacturers, insurance, labor, and enforcement, that we understand, for example, the manufacturers. We need the manufacturers to be economically healthy here, but also the public sector needs a voice that just presents a platform for sober reflection on some of these ideas. So that's all I want to say.
And you're right, Mike, but keep this in mind, that the A17 Standards Committee and many of the subcommittees, such as this went through mechanical design and a couple other committees, and when it did, all those manufacturers, their engineering staff that sit on A17 supported this action. So they're in the same issue. They're trying to make sure that their product is relatively safe and good for use of the public, so that they're not sued. And that's why they take such great detail, and they have the majority of seats on A17 Standards Committee.
Yes, as I'll remind our C-suite, we are the strongest. We are the strongest and clearest.
1110.
Yeah, we are the strongest and clearest user-owner voice for the public sector. Period. Where are we going next?
TN12 1110. That's it right there. Okay, and you'll notice that this has to do with escalator brake monitoring. Previous to this, you didn't have to have redundant safety, or excuse me, the escalator brake monitoring to have redundant safety is already required, but now is clarified with the appropriate language. So it's a language change, not necessarily a code change. So you go on to TN 12-1959.
Go ahead.
And it's what this is you're adding a requirement to identify the SIL-rated device on the print. What SIL is the safety integrity level. It's a definition in the elevator code in section 1. A SIL device, when you put it on, in the past, many service companies would just replace a microswitch with another microswitch. But the microswitch that they replaced may not have the same safety level of failure as the switch that was in place to start with. So it was very important that they identified what the integrity level of that safety device is. So that's what, if you look in A17 in section 2, you'll find the SIL-rated devices. And the SIL-rated devices give what level for what type of safety device you're putting in. For a microswitch, for a relay, for an interlock, all those things. And it's important that it be replaced with the same thing. So this rule is making the manufacturer put it on the print as to what the safety integrity level is for that device, such as a stop switch. It would put the designated level that it started at, if it was a level 2, or if it was a level 3, or if it was a level 1. You look in the SIL ratings and you go 1, 2, 3, 4. 4 being very stringent, 1 less stringent, but still at a capable level to protect the integrity of that circuit. So that's what the SIL is, and now they're required to put it on their wiring diagrams so that if a field mechanic or an owner had to replace that part, they know they have to replace it with that same rating.
What is that part? It could be any part, really.
Yes, if you, like I said, if you go into the table in A17.1, it'll list the devices and what their integrity level is.
Okay, so what, in the back of my mind, I'm thinking about the problem we have with backflow prevention. It's generally an OEM one-for-one. You don't want to have competitors in the replacement part business.
Well, that's part of the issue. Personally, I think the manufacturers with the SIL rated in the code, while they're trying to protect their liability interest, they're locking it up because there's a related code that A17.1 uses, and that's called A17.5, which is the electrical specifications for any device used on an elevator. Or by A17.1 standards and A17.5 standards, you must replace like for like. Okay, so it limits a non-manufacturer, it could be
Right.
just a service company, to what devices they use.
Yeah,
Many times
yep.
it raises the cost and moves towards the proprietary rights rather than an open market.
That's one of the fronts that we deal with in a number of standard suites and product lines. So it's here. We can push back a little bit. Again, we try to be respectful of the manufacturers needing to recover their innovation, manufacturers being afraid of lawsuits if a counterfeit part is put in place. I get all that. On the other hand, we buy enough of this stuff, a million odd elevators, that we don't want to see confiscatory prices at the replacement part level when we're bidding on first cost. And it's a continual theme that we deal with. So I'm glad you bring it up here, Dave. Can we move along here now?
Yep, we're on to the next one. That's TN 130538. Okay, if you look at the rationale, it pretty much tells you what they're looking for. It's specifying a vertical clearance from the hoistway, etc. And what that is that from the guardrail that's on top of the car to the wall, this is a minimum measurement that it can be.
Now, would James Bond fit in there?
No.
At 4 inches, it's going to be a little tough.
Okay. Well, you know how Hollywood handles these exciting opening scenes. So anyway, go ahead.
It's a matter of, it's clarifying the safety intent of the guardrail on top of the car and the clearances to the handrail so that if you had your hand on the handrail, you're not going to rub up against the wall of the hoistway.
Mm-hmm. Okay.
Okay.
Makes
or
sense.
your clothing gets caught on a guide rail bracket.
Mm-hmm.
So that's the intent of it, is to keep the person on top of the car within the confines of the guardrail.
Mm-hmm. Okay.
So we're on to the next one, TN 130668. If you look at it, it says it's clarifying the definition of an emergency stop. Mike, you not being in the industry tries to keep emergency stops, which is the stopping of the car at other than a landing, to less than 1 G force. Okay, and an emergency stop also tries to keep the stopping of the car at less than 1 G force so that it doesn't impact the passenger or the riders of the car.
Okay.
So this particular item here is talking about how it removes the power from the driving motor, machine motor, and brake, so that it is in fact a fail-safe method to make an emergency stop.
So there's all kinds of emergency stop modes. I'm sure that's clarified deeper in the document. Do you hold the stop there? You know, all that kind of stuff. So from my old industrial controls world, sometimes process control emergency stops are different than elevators for life safety. So, okay,
Yeah.
What's next?
So on to the next one. That would be TN 130668, which is dealing with the 130668 earthquake emergency stop. 130668.
Oh, you want 0668? Let's see.
Yeah.
130668.
It's before where you were. Okay, that right there has to do with earthquake operation. Okay.
Let's see. 0668, huh? Okay, I don't see earthquake here, but okay, I'll take your word for it.
Go to the next one. I had it mislabeled on mine. Right there. Oh, go back. That was the emergency stop. Okay.
What number do you need, and I can search on it?
Okay, leave it right there on the Lula folding doors, TN 0868.
Okay.
Okay, And that's, again, dealing with a Lula elevator. And Lulas, as I said earlier, are limited use, limited access. We have a few on campus, okay? And for smaller buildings where they're not moving a lot of people, the Lula comes into play for low-rise application so that it's less costly than a full elevator and full standard commercial elevator, let me put it that way. And this does away with the folding doors so that in the private sector, there's been many accidents where a child was stuck between a bifold door and a landing door and drugged through the hoistway. So this reduces the possible gap and does away with the use of bifolding doors. Okay, so it's a safety concern. It changes the measurements that are allowable, and so that you're only talking about 3/4 of an inch from the back of the hoistway door to the sill edge, and 3 inches overall from the bifold face door to the edge of the sill. So testing in as a result of deaths that were incurred on this type of device, the Lula and the bifold door, was that a child head works out to a little better than 4 inches. So they tried to minimize that space so that a child's head, the car wouldn't be able, the child would not be able to be entrapped between that space between the car door and the landing door. So that's what they were trying to do, and that's what this rule is about.
Okay.
It's great to see this actually addressed from a code standpoint rather than just see it come through technical bulletins from manufacturers.
Yeah, absolutely. And that, it took them, as you well know, Terry, Mr. Koschak has been very involved with that, and he's a consultant that he's given testimony at many accidents involving children on this type of device with a bifold door. And
well, it adds some standardization, I suppose. There's less of an option for manufacturers, so I see this as gaining in several
manufacturers didn't see a problem with reducing that depth.
No.
It was more a point of what material they could use because there's limited space in that area, and that's why it was such a big push for the manufacturers to get this going.
Okay, good. Let's move along.
Onto the next section is TN 13.10.41, and all it is an addition and clarification in section 1 of definitions related to what a controller motor is. And as you can see right there, it's to align the definition of motor controller with listing certification requirements, because not all motor controllers include power conversion equipment.
Well, on that note, I did scan parts of the NEC that we were talking about the other day, and we're behind. We can't do anything. Motor control is probably a concept that comes from the NEC, and these are the first principles for them. I think you and I talked a bit about the driven equipment here needing a disconnect. That's not necessary. So anyway, some work probably needs to happen here, but I thought I'd tell our audience at the moment that our earlier discussion on the YouTube link from a couple days ago, as we were preparing this and looking at the Michigan Elevator Code, that some of that is discussed in detail. So there's some correlation with NEC 620 that has to happen. But for the moment, our topic here is A17. Do you want to keep moving along, Dave?
Yes, but I'm going to dwell a little bit on this.
Oh, you are.
The issue is that the definition in A17 means that the elevator contractor and manufacturer has to abide by what's in A17.1, and it takes preference over what the definition may be in the NEC. And it's very important because that's what the manufacturer is going to make his equipment to, is A17.1, keeping in mind that he also has to follow the rules of NEC. So we can move on from there. It's just wanted to make that stipulation because the elevator manufacturer is required to follow A17. When there's disharmony between the two codes, it's up to the code bodies to straighten that out. You ask for interpretations to the individual body to clarify it. And when they clarify it, that's how these definitions come about.
Okay. Next.
Okay, the next is TN 131151.
Got it.
And that goes back to the spacing between the slats on the bifold door and scissor gates out to the landing that we discussed previously. So we can move on. We go to TN 131313. Okay, and if you look, it was strictly a clarification of language. It had nothing to do with requiring anything more stringent. It was already there, but there's interpretations came in, or questions for interpretation, and they felt that it was poorly worded to start with, so they went to clarify it, and this is what they came up with. Go on to TN 140614. That's section 8. It has to do with door restrictors. If you look at the rationale on that down at the bottom, okay, if you look, go down, I think it's on the next page, it might be in the middle of this one. Right there, you see how it's blended in? Remember when I said what A17 section 8 consisted of?
Yep.
It consists of installation, repair, modernization, testing, maintenance. All those things fall into section 8. And what they're doing is making sure that section 8 meets the same requirements as section 2.
Okay, harmonization. I like it.
Yep.
Okay.
Okay, then we go to 140686. This has been required in, and this is for dumbwaiters. Dumbwaiter controllers usually sit on the floor, or when I say sit on the floor, they're mounted on the wall in an exposed area that the public may be able to access. And this puts in place the same as the National Electric Code, requiring it to be a locked cabinet. And that lock is accessible only by authorized personnel.
Okay, we can have a larger discussion about authorized personnel on this one. So that's probably not a venue for, we want to get through this, and we're doing a good job here. So that might be, we'll call a flashpoint there.
Well, to your question on defining authorized personnel, the beginning of section 8 defines it. Okay, so you have to look in A17.1, section 8, and I think it's like 8.2 or something like that, or 8.3. And it says what authorized personnel is, what elevator personnel is. Authorized personnel are fire marshals, elevator personnel. It's a big group. Then you get into minimum other requirements. So.
Yeah, okay. I know that always I get paid to ask tougher questions about that. What part is that?
Section 8,
8 what?
security.
Security. Okay, I get that. I remember. I just somebody has to ask the question, and why is this being done at a national level? I know the NEC. We avoid. That's always that's a standard assertion by the by the labor associations. So it's gildishness, as we say.
Yeah, go back a little bit.
1.3, Mike.
Oh, I'm sorry. Did I get that right? Let's go by 1.3, 1.3. 8, 1.3, you say?
I'll have to go back up. Right there, 8.1.
I get it. Okay, I got it. All right.
It defines the group. 8.13 says who the group is.
Okay.
Group 1 is a restricted key. It's always restricted for elevators.
Okay. So, all right. So that's we can talk a half an hour on that one. Let's get through. Yeah. Let's get through this. Okay, go ahead, Dave.
Okay. So let's go on to let's see right there, 1169. 1169 is actually the two devices are already required, okay, and it's just putting in language that they both operate the same, okay. You see where they add and deactivated? Previously, there were some manufacturers that would not deactivate the device at the same time. So there was always some confusion. So what they did is they went back in and added the language and deactivated so that they operate simultaneously.
Makes sense.
14.15.02 is editorial, and it deals with the seismic calculation, which we're not going to really get into because it's a set standard defined by the building code, and that all they did was harmonize it with the building code.
Why did they take out the structural engineers? I'm actually working on this standard right here on the live loading part, but anyway, that's a different discussion. Why would they take IBC? See, if you talk to the IBC people, they like to reference back to the ASCE. ASCE wants the. There's some handshaking that goes on between those concepts, but that's another discussion. We have a project on that one, but go ahead on this one.
Okay, what it was, Mike, was that the requirements in the building code define how the elevator is supposed to act, and it wasn't in the structural engineers. Structural engineers.
Oh, I get it. Okay, all right. Okay, I get it. Thank you.
Okay, so then we go to 14.15.96, and that's about tags. Michigan's unique in that they do not require a metal tag that other jurisdictions do. Michigan only requires a paper tag. It's now printed by the contractor or the person performing the test and has to be sealed on the governor or the carrier, not the governor, but on the carrier, on the safety device, the buffers. So tags are always an issue. The state of Michigan quit printing the tags the end of last year and now puts it on the owner to print that. It's always been a sore point with me. They want us to tag it, but they don't supply it.
I think we're talking about two different tags here. This TN 14.15.96 is about the data tag and not about the test tag.
Yes, but it all goes back to the same thing. The data tag is metal tag. It's affixed to the equipment.
Right, and that is required.
It is required, yes. But also goes back to that point that I had talked to Mike about before. The state of Michigan did away with supplying test forms and tags, adding to our cost.
Yeah.
Okay.
So, and it was an editorial change, so it's not a... Okay. So 14.16.32, Section 7.
looks like just some new language.
It's an editorial.
Okay.
Okay.
This looks like a reference. They've clarified the reference.
TN 14/1894 is an editorial. Okay, they actually added some information on the table is what they did.
For
Okay.
wind turbine elevators? Okay.
Yeah. And that's our next item, 1896, I think it is. Yeah, 1896. Okay, all that did was add the wind turbine. The wind turbine elevator, or the wind turbine, has an elevator in it if it's a specific height. It falls under A17.1 and will be coming out in full print and full review of the A17 Standards Committee.
It's interesting. Some of them probably go up quite high.
Yeah, usually the tallest ones, they're looking at usually about 120 meters.
That's
Okay.
serious. That's plus sometimes they're way out in way out in the ocean. Yeah.
Yep.
All right. So
We're also in Lake Michigan.
yeah.
Yeah.
That's an interesting area.
concern. Yeah, the state of Michigan, just for your information, is the Elevator Safety Division is not addressing wind turbine elevators. They leave it to MIOSHA to defend.
Well, they've got a budget there. Who can be possibly against safety? So there you have it.
Yeah, but they've chosen to defer to MIOSHA rather than Bureau of Construction Codes.
Well, that's what I'm driving at, is that the enforcement budgets tend to be more robust and socially acceptable.
Yeah.
Isn't it easier to move money around a spreadsheet dealing with enforcement than with construction?
Well, the same thing with MIOSHA, and we could get into a long debate, which I'm not going to, but MIOSHA, they don't inspect on a regular basis.
It's enforcement by litigation. Yeah, that's my favorite concept.
Exactly.
Yeah.
Yep.
Okay.
So we're on to the next one, which is TN 14/2094. It deals with mine elevators, which I don't know of any university that has mines. But they could
Well,
have.
there's mining schools. I think Texas is agricultural mine. Texas A&M is agricultural mining, but I think not for academic purposes. So we can move past this one if you want.
Yeah. And the same with TN 14/2096.
Okay.
So go to 14/21/14.
Got it.
Okay. This has to do with the factor of safety. The rope shall not be less than those required by a particular section. So it's for harmonization and consistency between two sections and two rules.
Okay.
This one is, again, consistency for suspension means. Suspension has its own code. It's A17.6, falls under A17 Standards Committee. This, for the assignment, it's to align current language with, this is where your committee for structural comes in, on TN 14/24/39. And the seismic requirements for the driving machines, they change language so that it aligns with the current language in ASCE 7 requirements.
Are you sure it isn't ASCE SEI, Structural Engineering Institute? I mean, if we were to make a comment, there's many structural, I don't know if ASC 7, that might be a small editorial comment we might make on this. I don't know if there's ASC 7, it's ASCE SEI 7. Anyway.
I'm not aware of it being SCI, and they worked with the committee, ASCE, to develop that language. So.
Let's see, ASCE SEI 7. Yeah, looks like you're right. It is ASC7. Okay, got it. All right, enough of that. All right, the one I'm working on is the Structural Engineering Institute,
Yeah,
710.
it's a specific subcommittee of ASCE.
Yeah, yeah, I'm not going to spend any time on that. Okay.
Okay,
Okay, Chief.
so that deals with all the changes that are proposed for the future edition of A17.1 at this time. And
Mm-hmm.
you have to keep in mind that at this time, every uh, A17 standards meeting, they vote on TNs and TRs, and they put it forth, then it goes to public review. So you've got to keep a constant vigil to make sure that you don't miss something along the way.
Mm-hmm. Well, that's what we have you following the calendar right now. Where is the state of Michigan? So first of all, this will be the 2016 revision we're working on. How many states adopt this immediately once it's laid out fresh for the public use?
Uh,
25,
no,
35?
no, less than that.
Yeah. Okay, that's usually how it goes with this. Some states immediately adopt the latest version of the NEC, but
Well, yeah, you look at the standards and you go to Chicago, and for years they were under the 1980 edition, and they just changed that 3 years ago, and they're in the 2000 edition now, I believe.
mhm.
So
Do you have any
you can
BOMA?
see.
I'm sorry to interrupt you. Go ahead.
No, go ahead.
Do you have any BOMA? I don't think you have any BOMA people on the committee, Building Owners and Managers Association.
There's a liaison for BOMA, but uh, there's not much input there from them.
Yeah. Okay, I can imagine. Well, yeah, that's the. Okay, so I don't want to do web search here on a teleconference, but in any case, I get the point. They're the closest alliance with us, and obviously, the most important relationship we have is with Elevator U at the moment. Terry, do you have any thoughts, any reflections here? We're running on to an hour, and this is all very helpful, but I wanted you to have a chance to comment on anything that any statements Dave's has made, or maybe he has some recommendations.
No, not right now. Everything that's proposed right now by the Standards Committee is mostly language updates and harmonization updates.
Mm-hmm. Well, that means you guys aren't working. Not you. That means that committee's not working hard enough. There's not enough new ideas getting in there and shaking things
Well,
up.
I'm sure they're in the works.
But it takes 10 years to get there, and by that time the guy who proposed it's gone on to another more lucrative career. Yeah, yeah. So anyway, whenever we see a committee stall and there's no new concepts, one of the prescriptions I have is open it up to the public. Right now, it looks to me like there is a way for ideas to flow up into these committees, but I think, as I understand, ASME does have a filtering mechanism. So that the committee's not bogged down with what could be silly proposals. They actually are filtered by ASME staff. Do I have that right?
to a degree,
Yeah. Okay.
but if you write to ask a specific question related to the code,
Mm-hmm.
remember that's what everybody's right is to do that. ASME, the Standards Committee, and their subcommittee, you must remember that when they get the question in, they're not talking directly to the person that wrote
Mm-hmm.
the question. So therefore, they will interpret it, and they may change the language of the question so that they better understand it to make an answer from a code viewpoint.
Yeah, I get that. I would just like to see more ideas flow upward. I know the couple committees, 3 or 4 committees I've sat in over the past 20 years, when you get down to the point where you're just doing harmonization and correlation, and that's your work, that might be fine for keeping your travel time down, but and that may not be fine for the industry. Are enough ideas getting up upward into to the experts. So that would be my only overall comment. That doesn't actually go to this committee. That actually goes to the executive board of ASME, and by sure you will see that draft of that. Probably not by this deadline, but maybe afterward, because that's a largely procedural one. And I might even suggest they try to develop a new workspace. But that's a different discussion.
You have to remember, Mike, there's another standard, and that's A17.1. There's a performance-based standard that if you choose to bring a new idea to the marketplace, and the current code does not specifically cover it, A17.7, you can avail yourself of that and go through what's called an ACO, which is a testing firm to put your ideas forth. It's quite costly. It's quite costly.
Yeah, we run into this problem also else in the other standard suites is that enforcers don't like prescriptive or performance requirements. They want bright line language, black and white. They can check it off and bill and get out of there. You know, you get that mentality. So if this weren't going on for an hour, and I could talk a long time about this, and I think I'd rather pick up a topic of your choice farther out. This developmental cycle, I think this is about as comprehensive of a coverage of this document that certainly our industry has ever had. And for that, I'm very grateful for your expertise. I just want to make sure that within the hour that I've set aside for this, that I haven't missed anything that's of immediate importance, say, over the next 30 to 60 days. Do you have any thoughts that we need to act upon for the next 30 to 60 days, Dave or Terry?
Terry, go ahead.
No, I don't right now.
Okay.
I won't in the future.
I see. Okay. All right. So here's
one thing.
Go ahead.
One thing is that remember that the state of Michigan, and that's who we deal with, is in the 2010 edition. Mm-hmm. 2013 has been out for 2 years. Mm-hmm. Okay. They haven't adopted it. They haven't even looked at it to say that we are going to adopt it. Mm-hmm. So we're quite a ways out of the box. We have to get Lara to understand that if national standards are moving forward, that we have to get a better method to get the manufacturer's product that's approved under 2016 can come into this state without modification. No.
Maybe I'm hearing this different. What I think I heard is what I hope I heard, which is that if we could move the acceptance to the promulgation or the acceptance of these standards faster, if we could compress that time frame, there might be some economy there. Is that another way of saying what you just said?
Yeah.
I like that.
And there is, because when a manufacturer has to modify his equipment to meet a specific standard that was in the past.
Of course. That's obvious. Why did I think of that? Brilliant. That's a major policy. Now, of course, in the residential space, we have to deal with a very powerful lobby, the home builders, and they reach into everything, as you know. And I'll say this to Lee Schwartz, who might be listening to this. Look, Lee, you're in the residential space. In certain technologies, Lee, we think that our standard suites need to move a little bit faster. And even though we're outnumbered and frankly always outsmarted by the home builders lobby, we are here to stay. And I would like to give Dave's idea here of moving faster in the code adoption some expanded audience. So with that, I think we probably need to close this out, and I just picked a very nice topic for some focus session in the future. How much is the delay in the code adoption by localities costing those localities?
Well, actually, and I'll use an older example. It was the manufacturers had what's called a door bypass circuit that on inspection you could use to resolve issues with door lock problems. Mm-hmm. Michigan did not adopt that for a good 6 to 8 years after it was embedded on a controller, and it cost the manufacturers a good $3,000 to $5,000 per controller to make that change so that it could come into Michigan. Now, that's changed since that time, but when you start multiplying the number of controllers times the cost per controller, all of a sudden it becomes a major dollar factor. And if we bought 50 elevators at $5,000 a piece, you know, all of a sudden it's another elevator. You know.
Yeah. Okay. And finally, for reference, and I'll close this out and I'll upload this on to the project website very shortly. It'll be a long one. There'll be the short one without the titles coming up very shortly, within the next couple of days, and then we'll have a more polished version of this. These files will start out as 100 megabyte files, and we can run them up to 25 gigs once we wash them out of all the audio and stuff. So that's one of the reasons it takes a little bit longer. But this one will more or less be immediately uploaded onto the project website. So with that, I think I'm grateful. I'll put this up, and I hope that you're both hopefully I will see you before this conference, but I think you're both heading out there, and I wish you safe travels.
Thank you.
Yeah?
Thank you, Mike.
Okay, take care. Bye-bye.